Today we are having a class for the student who are going to appear in forthcoming board exams, and that subject is physics. Topic is from light, that is law of reflection. Law of refraction. So this law of reflection you have already studied in the 10th standard, as you have studied law of reflection also. In law of reflection, class of law of reflection, I told that up to 10th level we are dealing with the rays of light. Both law of reflection and law of refraction is dealt with ray of light. But in this level, that is in 12th level or higher second level in boards exam, you are dealing with wave of light. So you have to convert rays into waves. Then only you can do this law of reflection using wave theory or Huygens wave theory. So first you should know what is law of reflection and how board is asking questions in this topic. So first let us see some questions of this topic. So first question is, explain law of refraction with the help of wave theory. Second question, prove the law of reflection with the help of Huygens wave theory. And thirdly, third question is like this. Show that the velocity of light in air medium is greater than velocity of light in denser medium. So students, these are the three questions which are repeatedly asked in your board's exam from this topic, law of refraction. So first let us see what is laws of refraction. So this is law of refraction. First law, the incident ray refracted ray and normal lie in the same plane. That is first law. Second law is like this. Incident ray and refracted ray are in the different medium. And third law says ratio of velocity of light in denser medium is constant which is known as refractive index. With respect to their medium. So these are three laws of refractions which we have already studied in the standard 10th. Now we have to prove first two laws are already proved when we will draw diagram, and for third we have to derive it, then only we can prove. So let us see diagram of this law of refraction. So as usual, first we will draw xy, that is plane. XY is a plane. Here air is medium. Refractive index mu1. Here glass is medium. Refractive index mu2. Now, this is your incident ray. You can say AB is incident ray on the point, you can say M. And this is your normal, that is M1. M2 is the first normal. Now this is the way of actual way of ray of light AB when extended like this, but it will deviate. Little deviation is there. So new way, path of the ray of light is this, that is you can say C and D. So this is simple way in which we can explain how ray is deviated. But here we are not considering with ray. Here we have to consider waves. So the number of rays consists of number of, that is a single wave. So we will consider second incident ray like this. This is second one. So we can say this is your A1, B1, this is your normal N1, N and N2, this is normal way path and this is deviated path. So it will C1, d1. Now, since ray is coming from air and it is inserted in the glass, so your rays will deviate, means it will come towards the normal. So we will have here a spherical hemisphere. This spherical hemisphere is considered, and from here there will be a tangential touch, or you can say tangential collections of particles. So this will be right angle. This is known as angle of incidence I. Here angle of refraction R. Again in this ray also incidence I, and here R. So here we form a spherical form of waves which is tangential to reflected. Here we will have AB is this you can say AB is a wave, that is wavefront. When this collection is coming to this in refracted area, that is in glass, it will come in the form of a sphere, and this hemisphere shows how it is converted this wave into wavefront. So let us see how we will prove it. So first thing you will see, first point, let xy be the plane distinguished by denser medium, air, and rare medium, glass, having refractive index mu 1 and mu 2 respectively. Secondly, AB is incident ray, M1, M2 is normal, and CD is refracted ray deviated towards normal. See, this is incident ray, this is refracted ray, and this ray is deviated towards normal. So it is making angle of refraction. Third point, I is the angle of incidence, and R is the angle of refraction. So next, next point you have to consider, this AB is the wave and this AB is the secondary wavelet, MB is the secondary wavelet which will come after time t seconds. So here time is also considered. So next point you will see, according to Huygens theory, these primary waves generate secondary wavelets, and due to this secondary wavelet we are getting this hemisphere and tangential form. So next point, all the rays between A, B and B1, I mean A1, B1 will come in the form of waves, and wave theory implement from this end to this end, that is AB to PB in t seconds. So you can write third point, all the rays between AB and A1, B1 is will spread over the hemisphere increasing ready in the glass as shown in the figure. Next point, A1R and B1R are refracted rays, that is path is deviated from original one. Next, let C1 and C2 be the velocity of air, velocity of light in air and glass. Next point, at any instant of time t, at any instant of time t, distance covered by incident wavefront and from AB to PB1. And distance covered in refracted ray as shown in the figure. Next, now see how derivation is carried out. So from figure, angle A1M plus angle MAP equal to 90 degree, and angle MA1P plus angle PA1B equal to 90 degree. This is first one, this is second one. From 1 and 2 we get angle A1M equal to angle PA1B, PA1B1 equal to I, that is angle of incidence. Similarly, we can show angle NAR equal to angle N1B1R, that is angle of refraction, equal to R, that is angle of refraction. Now we have angle N1B1R plus angle N1B1R1 equal to 90 degree, that is third. And similarly angle N1B1R plus A1B1R equal to 90 degree, that is fourth one. Now from equation 3 and 4 we will get angle NA1R1 equal to angle A1B1R, that is R, that is angle of refraction. Now in triangle A1PB1, sin I equal to PB1 upon A1B1 equal to CT upon A1B1, that is fifth one. And in triangle A1RB1 sin R equal to A1R upon A1B1 equal to C2 upon A1B1, that is 6. Then divide equation 5 by 6. Divide equation 5 by 6. So we will get sin I upon sin r equal to C1t upon A1 B1 A1 B1 upon C2t. So this will cancel, it will come C1t upon C2t. But C1 T1 equal to mu1 mu2, that is refractive index. Therefore sin I upon sin R equal to mu1 mu2. So this will be proved. That is sin I upon sin R equal to refractive index of denser medium to refractive index of rare medium. So in this way we can prove law of refraction and we can show derivation of the thing. One question I told regarding show that velocity of light in denser medium is greater than velocity of light in rare medium. So for that, from the law of refraction, we have angle of incidence is greater than angle of refraction. Hence, major angle I is greater than major angle R. Therefore, sin I is greater than sin R. Finally, sin I upon sin R greater than 1 and mu1 by mu2 is also greater than 1. But mu1 upon mu2 equal to C1 upon C2, that is velocity of different media. Velocity of, you can say, air upon velocity of glass. Hence, C1 upon C2 is greater than 1, and we can say C1 is greater than to C2. So this is proved that velocity and denser medium is more than velocity in rare medium. So friends, this is the most important questions from chapter light and hygiene theory. In any form they are asking question in board exam, and this will vary to, if derivation is asked, it means it will become near about 4 to 5 marks question. So this is most important topic for you with respect to board exam. So friends, as you have seen this video, you should see that these important topics you should clearly attempt and you should get more mark. So you subscribe, like and comment on the, and next time I will come with some other topic or some objective questions for your board exams. Thank you.